In today's video, we'll be looking at the spectroscopy of alcohols. Alcohols are, of course, compounds with the hydroxyl or OH group on it. And we'll look at the IR, the mass spec, and the NMR of these types of compounds. So in the infrared spectrum for alcohols, let's draw 3000 here, 2000. So in the infrared spectrum, you might remember that one of the most famous peaks in the infrared spectrum, one of the easiest to see, is the alcohol peak. And the OH bond in an alcohol vibrates somewhere around 3300, and it's always this big, broad peak. And then if we have, let's pick something like this. So this bond is this one at 3300. You also might see sp3 carbon-hydrogen bonds right below 3000. Different shapes. And the other peak you might see before you get down in here into some fingerprint region is sometimes there's a peak that shows up that's pretty strong. That's the carbon-oxygen single bond. This bond right here, the carbon-oxygen single bond. It shows up somewhere around 1000 to 1200, usually a little bit stronger than you normally see in the fingerprint region. But it's hard to tell because it's inside of the fingerprint region. So this peak for the OH bond is really the key for alcohols. If you have a compound like this in the mass spectrum, what happens sometimes is water falls off. So when the water molecule falls off, water weighs 18. So you might have something that weighs 88 is what this M plus peak weighs. And this one would weigh 70. So if you see a loss of 18 in the spectrum, so the M plus of course would be 88. And if you see 18 fall off and you see another peak at 70, in this case, the loss of 18 is an indicator that you might have an alcohol. It doesn't always happen that way, but minus 18 is just one small indication for alcohol in the mass spec. Otherwise, in the mass spec, there's not a lot of clues. In the NMR, let's look at the carbon NMR first. Carbon atoms that show up next door to something special like the oxygen in an alcohol, these carbons show up between 50 and 100 parts per million. So if you see a peak in the carbon NMR somewhere between 50 and 100, that indicates this carbon. Any carbon that's farther away, they tend to be 50 or 0 to 50 in the NMR, carbon NMR. For a proton NMR, let's pick ethanol. Proton NMR, of course, we're looking at the hydrogens. So in this example, we have from 0 to 10. Hydrogens that are on a carbon next door to the oxygen, they usually show up 3 to 4. So in this case, we'd have a quartet. These would be regular ones. Next to these two, they'd be a triplet somewhere around here. And the alcohol hydrogen can show up anywhere from a half to maybe 6 parts per million. And you might see just a little broad peak like that for the alcohol. Now remember, in the proton NMR, that tends to move depending on the concentration of my sample, the temperature in the room. Because of the hydrogen bonding involved, that proton can move within my spectrum from one sample to the next, from one day to the next. The other thing I want you to remember about these protons in a hydrogen NMR is if I take this sample out of the NMR, take the NMR tube out, and shake it with heavy water, D2O, that this hydrogen gets exchanged for deuterium, and this peak disappears. So my quartet would be in the same location, my triplet in the same location, but this peak would disappear, and you wouldn't see it. So that's a way to tell where the OH peak is, because it disappears when you shake it with heavy water. That's it. That's the spectroscopy that you should know for alcohols. I hope that's helpful. Check out some of my other videos on alcohols and other organic chemistry topics.